Hi Sec3s, today we will be looking at gain or loss of electrons for redox reactions. Here we have an acid metal reaction where magnesium metal reacts with hydrochloric acid to form magnesium chloride and hydrogen gas. I've written both the chemical and ionic equations here. Before we start, we must remember the definitions of oxidation and reduction reaction involving electrons. We can use the acronym LEO and GER to remember that loss in electrons is oxidation and gain in electrons is reduction. From the ionic equation here, we can see that the magnesium atom has lost electrons to form an Mg2 plus ion. I will write both their electronic configuration down after determining the proton number of magnesium by looking at the periodic table. So as you can see, for magnesium, after looking at your periodic table, we should see that magnesium here has a mass number of 24 and a proton number of 12. So its electronic configuration has to be 2, 8, and 2. So now for a magnesium atom to have a complete electronic configuration, it has to lose 2 electrons. So the magnesium 2 plus ions here will have a electronic configuration of 2 and 8. So this means that it has lost 2 electrons. So as we know, loss of electrons is oxidation. So from this information given here, we can actually write the oxidation half equation involving magnesium and magnesium Mg2 plus ion. Okay, so maybe let's write it down. So one magnesium atom lost 2 electrons to form Mg2 plus ion. Okay, logically speaking, this is correct. However, in chemistry, we do not write equations involving the negative sign. So what we are actually able to do, so here is actually wrong. These 2 electrons in chemistry we will have to bring over to the right hand side. Okay, so this is how we do it. We remove the 2 electrons here and we'll write it on the right hand side. So this will be our oxidation half equation for magnesium metal and magnesium ion. Okay, so now let's look at the 2H plus ions present in this reaction. So here for H plus ions, if we look at, okay, so first let's look at the periodic table for hydrogen. So hydrogen has a mass number and proton number of 1. So for H plus ions, because it has already lost 1 electrons, so actually it does not have any electrons. So for H plus ions, it is just 0. So here we can see the product formed on the right hand side is actually hydrogen gas, a diatomic molecule. So so actually the 2 H plus ions here, right, they have actually gained 2 electrons to form H2, 2 times of 1. Okay, so what happens is it forms hydrogen gas. Okay, with 1 covalent bond, and so they have 1 electron each, and they're actually sharing together in a bond pair of electrons. Okay, so maybe with this information we know that the gain of electrons is actually reduction. So from here we can actually write the reduction half equation. Okay, so now we have 2H plus ions and he has gained 2 electrons to form hydrogen gas. Okay, so this is also correct because there's no negative sign in the equations. The electrons here is in positive sign. Okay, so can we see here that for both the oxidation and reduction half equations, there are 2 electrons each on both sides. From here we can actually cancel both of them away. So actually for both oxidation and reduction half equation, we can actually combine them together to form a chemical reaction, the overall equation can be obtained using when both equations are added together. So as we can see, when both of them are added together, we're actually able to obtain the full ionic equation again. So it's important to note that in a redox reaction, the electron gain is equal to electron loss. So now when both electrons, so what actually this means is that the two electrons lost from a magnesium atom, when it forms Mg2 plus ions, the two electrons will combine with the two H plus ions to form hydrogen gas. Okay, so as you can see, these two equations here are the same. Okay, so maybe let us look at another example now, when sodium metal is used instead. So now instead of magnesium metal, let us use sodium metal. Okay, so in this case, because hydrochloric acid is still the acid that was used and hydrogen gas was also formed, we are only changing the metal. So for the reduction half equation, it will be the same. So let's just write it again. Sorry. Okay, so now for sodium metal, sodium is actually just next to magnesium. So sodium has a mass number of 23 and proton number of 11. So its electronic configuration will be 2, 8, and 1. And for it to form Na plus ion, you have to lose the extra valence electron it has. So for Na plus, electronic configuration is 2 and 8. So given this information and that loss of electrons is equal to oxidation, we can also write the new oxidation half equation again for sodium. So intuitively we are losing 1 electron, so maybe we can just write it out like that. But I think as you are getting used to it, right, we can actually know that we do not have to write the minus electron here. We can simply just put it on the other side already. But maybe let me show you what we should actually get based on logic. Sodium atom loses 1 electron to form a sodium ion. So for here, just now we mentioned, here we cannot write it this way. Let us shift it over to the right hand side. Okay. So this should be the oxidation half equation for sodium. So now remember when we said that in a redox reaction, the electron gain has to be equal to electron loss. However, now when we look at it now, for the oxidation half equation, there's only 1 electron involved. Whereas the reduction half equation now, we have 2 electrons being involved. So now actually we will have to balance the electrons out now. So in order to balance the left hand side and right hand side, we can simply multiply the oxidation half equation entirely by 2. So now the number of electrons involved here is 2 electrons now. So now can we see that there are 2 electrons both on the left and the right hand side. So now we can simply remove these, and we are able to cancel the electrons away. Okay, so now we'll put an addition sign here, and then from here let us add both the oxidation half equation and reduction half equation together, and we're actually able to obtain the overall equation of okay, so actually we can realize here the overall equation that we have written is actually the ionic equation for when sodium metal reacts with hydrochloric acid. So in this case here, we can actually, if let's say we are using hydrochloric acid, we can actually add add the spectator ions back in. So there's like a chloride ion, spectator ions here. We can also add the spectator ion back, and this, from here we can actually obtain the full chemical reaction between sodium metal and hydrochloric acid. Okay, so yeah, so oxidation half equation and reduction half equations are essentially just how ions are being formed, and also the process when electrons are being transferred from one substance to another. And using this information, we can actually also form overall equations from it.